Now we'll see a problem related to uncertainty principle. The problem is that an electromagnetic pulse has a pulse width of 10 power minus 3 seconds. The uncertainty in the momentum of the corresponding photon is of the order of 10 power minus n kg per meter per second, where n is an integer. Now the value of n is, and given the value for C and H. This is the problem occurred in GATE 2022 in physical science. We know that uncertainty principle states that some pairs of physical observables cannot be measured precisely and simultaneously to an arbitrary accuracy. And according to Heisenberg uncertainty principle, delta P delta X is greater than or equal to H cross, and delta E into delta T is greater than or equal to H cross. This is one in momentum position uncertainty, another one is the energy time uncertainty. Now we will consider a non-relativistic particle of speed v with a rest mass m0 and a momentum p moves along the x-axis. So the total energy is your rest mass energy plus the kinetic energy p squared by 2m0. Now you differentiate this equation with respect to p, then you can get delta E is equal to p by m0 into delta p. And p by m0 is your velocity, so delta E is equal to v into delta p. Now you substitute this in equation 3, then it becomes delta E into delta p is greater than or equal to h cross v. So this is now in terms of energy position. This is for the non-relativistic case. If you consider for relativistic case, then it is h cross c. Now you multiply equation 4 with delta t, then it is delta E into delta t is equal to V delta P into delta t, which is greater than h cross. So here uh, delta P into delta t is greater than or equal to h cross V, and if you write this in terms of for the relativistic case, then it is delta P delta t is greater than or equal to h cross by. Now if you consider a photon, then E is equal to Pc. So for this case, if you differentiate this with respect to P, then it is delta E is equal to C into delta P. So delta E multiply both sides with delta X, then delta E into delta X equal to C delta P into delta X. So generally the position of the photon is expressed in terms of lambda, and momentum of the photon is in h by lambda. So it is delta E into delta X is hc, and delta T of the photon is your lambda by c. So delta P into delta T is delta P into lambda by c, that is equal to h by c. And it is given that in the problem delta T is equal to 10 power minus 3 second and delta P is equal to 10 power minus n kg per meter per second, and also they have given C is equal to 3 into 10 power 8 meter per second and H is equal to 6.6 into 10 power minus 34 joule second. So delta P into delta T is your H by C. So now you substitute the value, then you take log on both sides, then you can get n is equal to it's approximately 39. Thank you.